Horizontal asymptotes, good. Horizontal asymptotes. So, number 2, why was 1 through 6 kind of weird and kind of tricky? I totally agree that it was. Yeah, you had to match graphs. And did anyone notice that like 4 of them had horizontal asymptotes of 2? Was it like 3 or 4? So like what were you supposed to, well, hold on. First of all, horizontal asymptotes of 2. How did you guys know that? Well, yeah, this, no, yeah. Why does this have a horizontal asymptote of 2? Isn't this bottom wins? Good, but you still have the, so 2 plus 0 is 2. So there were 4 different, was it 3 or 4? There were 3 or 4 different ones that had a horizontal asymptote of 2. This one had a horizontal asymptote, it was tricky, of plus or minus 2. This was the one that had 2 different horizontal asymptotes. That's why it matched with C. Why was it plus or minus? Check the sign. It's a tie. What would happen if you went to positive infinity? A positive over a, but what would happen if you're going to a negative infinity? A negative over a, so he was the one that had 2 different asymptotes matching with C. 4 was the one that had only 1 horizontal asymptote, but if you didn't know how else to match it, couldn't you have plugged in, didn't they all have different y-intercepts? Could have just plugged in x equals 0 and kind of been like, this one, oh, this one has the point. Let's see, when x equals 0, 0, 2. This one was the graph that had the point 0, 2. They also talked about vertical asymptotes, whatever, yada, yada, yada. This one also had a horizontal asymptote at 2, but its 0 would have been very different. Its 0 would have been at 5. So this one had an intercept at 5. That one had an intercept at 2. That's what I would have done. But some of you, I know, it was kind of hard because you're like, they all have the same horizontal asymptotes. Anyway, did you guys get the answers? I apologize. I was just talking. That's C, that's A, and that's E. Good? Okay. Number 10. How did they approach infinity? Well, they said 10 to the 0, 10 to the 1, 10 to the 2, 10, 100, 1,000, 10,000, 100,000, a million. Could you have done 17 and 170 and 500 and 2,433? Yeah, you could have done, all you needed was the table to get bigger. Wait, did they give you the table? Oh, so you were just plugging in. Well, that's lame. What was going on? It's getting closer and closer and closer to 0. Number 14. I don't mean to move you. Okay. Number 14. A, D, and E. But, ooh, that's not the proper answer. Negative infinity would have been the proper answer, right? Letter B, -4, and letter C, 0. Bottom wins, it's a tie, and the sign ends up being negative. And this one, the top wins, and the sign ends up being a negative. Really quickly, why is it negative? Doesn't a negative squared end up being positive? Some people would say, and they're horribly wrong. The negative is its own thing. It's -1 times 4 times x squared. Only the x gets squared. The negative is separate, so it makes everything negative. Good. Number 24. It's a tie. Ends up being 1/2. Is that good? Number 28. It's a tie. No, it's not. Who wins? Top wins. He has a square root. So plug in infinity, check the sign. Should have been a positive infinity. Should have been a positive infinity. Number 30. Now, guys, in their work, here's a quick heads up. In their work, are they doing degree tests or are they doing some weird, like, mathy stuff? Do you see this weird mathy stuff? When I grade your homework on this one and I see weird mathy stuff, what am I maybe going to think? You were just cheating from CalcChat? Why? We did not do the weird mathy stuff. I told you that the degree tests were a great shortcut as long as you watch out for checking the signs. Okay? The weird mathy stuff. Could you learn that anytime you do a problem like this, you look at the guy to the highest power, and then you divide everybody by the highest power. Divide by x squared, divide by x squared, divide by x squared, which would put 1x under the square root and 1x out. Ooh, 1x out and 1x under. Yeah, we could have done that way, but it just makes everything so much more complicated. So I don't think you should be doing it that way. So when they show this, they're not wrong. They're totally right. This is the mathematical way of breaking down the degrees to see who's left, and who's left is this guy. But my way would say, hey, who wins? Bottom. Why bottom? Square root of x to the 4th would be an x squared. X squared times x squared is x to the 4th. So that's really just like a quadratic-y one. That one wins. And so therefore, since the bottom wins, the limit is 0. If you want to learn the mathy way, I mean, we technically have an extra day until the test. You can come in. I'll show it to you if you think that would be helpful for your brain. But otherwise, I would say let's not. There was another one, right? Is 44 the next one? Oh, dear. Oh, there we go. 36. Final answer is 1. Now, this one could have been a little bit hard, except didn't we talk at the very end of yesterday? How strong is he? Not that strong. He just goes between 1 and -1, whereas x is going to positive infinity and negative infinity. Cosine's degree is not strong enough to do much of anything. He's just in this little between 1 and negative quandary for forever. Those guys are going to go ahead and be increasing or decreasing without bounds. So they're my strongest. What's the ratio of leading coefficient? Got it. Now, there is this snazzy thing called the squeeze theorem, and BC will talk about it. But long story short, 1. Bottom wins 0, right? Were there 2 parts to this problem? Oh, okay. Okay. So that little piece, the limit is 0. But when you come to look here, you could say that there's a tie. And you would take 4 over 1, but you would check the sign. But a positive over a positive would be a positive 4. And last but not least, at least on this page, sorry. Degree tie. Why is it 3? Why not 9? Square root. Good. We're not actually taking the square root, not killing a puppy. We're not like multiplying or anything with the square roots. But we are saying this is going to end up being a linear with somehow a 3 involved. So therefore, we could go ahead and take 3 over 2. But did you guys realize that going one direction would have been a positive number, going the other direction would have been a negative number? There were 2 horizontal asymptotes. Like that one from, what was that, number 4, the one that you had to match that had 2 different horizontal asymptotes. Okay, do we have more evens? Oh, that's it. Do you guys have any questions on the odds? Yeah, let me grab out the notebook real quick, just so I have space to write them down. Patricia, I saw yours first, kiddo. What's going on? 55? Do we have anything earlier than 55? AJ? Which one? 53? Okay. AJ, what was the question for number 53? I'm guessing that we're finding a limit. Okay. And it was the limit as x approaches of? Ooh, negative infinity? Uh-oh. You might have written down the wrong problem, kiddo, but let's double check. Negative infinity of what function? All over x? Oh. Got it. So still up there. Oh, it's not a fraction? Ooh, this is a nasty one. Oh, I forgot I gave you guys these ones. Let me, for sake of illustration really quickly. Patricia, is yours, what? I don't know what's, stop. Sorry. Was yours similar, Patricia, your question? Like one of the ones where it was like a string of, oh, no, it's different. Okay. Let me pull up the solution manual. Because you guys can't see the calc chat for the odds. All you can see is the final solution, right? Oh, no, you can find the calc chat. Let me go see what you guys looked at when you went to calc chat for these ones since they are odds. We're on section 1.6. We're going to number, AJ, yours is 53, right? Okay. Now here's the nasty part. For all of our degree tests, don't we need a fraction technically? Okay. For our purposes, we technically need a fraction. Now, if you were to look at this and if you were to plug in negative infinity, you would say negative infinity plus, and then that little guy would be like a 3x. You're like negative infinity plus infinity, so maybe it would be 0. And that's the initial thing that most people would think. But the problem is, do you just have these 2 parts? Or do you have an additional part too? So really it would be negative infinity plus some sort of positive infinity plus some more infinity. So if you have, are these really the exact same infinities that we can cancel out? No. Now if they were a fraction, I think Rachel, you and I were talking about this yesterday. If it was a fraction, we would be able to go ahead and simplify. But the problem is with infinities, If we know in a fraction, we can look at like numerators, denominators, who's stronger, and we can, based on that, know what happens going to 0, going to infinity, going to a constant. But if we just have them being added and subtracted, we don't truly know if they're the exact same. And this one won't be the exact same because I didn't plug in, I think, Rachel, this is where I got messed up. I didn't plug in this guy to see that it's going to add and make this infinity stronger. Does that make sense? So since it'd be minus a negative infinity, making it stronger, then these don't actually cancel. I can't say 0. So what do I do? How do I do a degree? Oh. How do you get a fraction when there's no fraction? You multiply by 1 creatively. So they went ahead and said, well, I need a fraction somehow. I guess I could do a conjugate. So they do a conjugate top and bottom, and all of a sudden when you FOIL, the first one gets squared, outer inner cancels, this guy gets put together. You end up with a fraction. And with that fraction, now you can go ahead and look at this and say, what's going on? Who wins? Well, the struggle is it's a tie. But why is that still tricky? Because you look at, well, that's going to be a 3x, and that's a 3x, and that's an x, so is that a 0 number over 0 infinity? Now we can look at the end and say, no, it's not infinity. It's a 1/6 actually. But the problem is the only way to solve this one, which is more complicated than any that I've seen on any AP test or any of my tests. So I don't see it as an AB question, although it definitely falls under the AB topics. This one would need the algebraic approach. And the algebraic approach would multiply everybody by 1 over x. So 1 over x, or divide by x, you could say, would be 1. 1 over x would be 3. Now it gets tricky when we go in here, because we can't go in the square root unless we think about what x is equivalent to under a square root, which would be square root of x squared. The reason they're doing negative is because it's plus or minus, but we're going to negative infinity. They go ahead and divide that under, and only when you go ahead and solve this puppy out can you see that actually at the end of the day, it ends up being 3 plus 3. This little guy will go to 0 as I go to infinity or negative infinity. We know that guy goes to 0. And we actually end up with a 1/6 left over. So these ones that I assigned you guys was kind of just showing you there are harder problems out there where our shortcut degree tests are not sufficient. First of all, degree tests need a fraction, so we would have to totally change the problem, but then the algebraic would come. So the algebraic approach is super helpful for really, really tricky problems, but for most of you, and for our AP problems that I've seen at least, the degree tests are sufficient and they do save you time and work. Does that make sense? So then, Patricia, yours was it 55? Okay, 55, you can just check out the process. It's the exact same thing in the sense of, I mean, you could have gone to a table and you could have looked at it, which wouldn't have been solving it, sadly. And the other one, if you had done that one, you would have gotten in the table 0.166666666, so you would have seen it. But this one multiplied by a conjugate, went ahead and got it here. It went ahead and did that nifty trick of dividing by the highest degree, which is going to be x again. Divide. This one, since I'm going to positive infinity, they're going to divide by positive square root of x squared, which ends up simplifying here. That goes to 0. You end up with 1/2. So it is a very mathematical approach. It is very, very possible. Just for our purposes, the degree tests have been sufficient for the CalcAB level, but there are harder problems out there. Did I cover both? AJ and Patricia? Okay. Let's go ahead and go to your guys' bell work, because the bell work with the AP prep for section 1.6. Thanks, guys, for the questions on that, because those were definitely super tricky. And I answered it really fast without fully doing the work, which usually is okay. But when I use the CalcAB shortcuts for non-CalcAB problems, we know that anyway, though, don't we, guys? Shortcuts work, but every now and then they get you in trouble. Okay. So even I, using the shortcuts yesterday, solved those two incorrectly. What do you guys see on your classroom? This was the one due at 7 a.m. this morning, right? Who's this guy? When's he due? 7 a.m. tomorrow, the test review. And then, who's that guy due Thursday, the day of the test? Let's check out these really quickly. Chapter 1 test review, when you guys look at it, let's not look at the student work. It's just going to be a normal, I didn't put a page number. I am so sorry. Did anybody figure out what page I'm talking about? 118? Thanks, kiddo. That's rough. page 118. This is a required homework assignment. Just like last year, I don't make homework numbers for the reviews. I have them, in my mind, being like a totally separate homework assignment. It's like homework, 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 review, and the TAs when they grade your homework spirals when you turn them in. P.S. Aren't I already grading for attempt and work shown and directions, problems written out, formatting? Aren't I already grading that in Google Classroom? So what am I going to be grading when you guys turn in your homework spirals on Thursday? Grading for everything but the, see, I keep it separate for the TAs so that they grade it differently. Grading for everything but the review. And are you just supposed to be like, oh, wrong, 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 wrong. Next homework. Oh, look, I did that one. No, it's wrong. You're supposed to grade and correct. Now, you're not supposed to do correction sheets or any of that and like analyze what you did wrong and write it out. But you are supposed to have some, like, not just grading, but correcting it and figuring out how to do it right, which that's what class time is for. And we try to correct any ones that you don't know how to. Some of you might need to, like, when you mark things wrong, come back to it, or maybe come after school or come during a zero period. You can get your math period stamped by coming in and being like, I didn't know why I'm wrong on this homework problem. So I'm grading for correcting, and for, do some of you guys not get to totally finish your homework when you turn in pictures? I mean, some of you fully attempt it, but some of you are like, I get stuck, and you put little question marks, and as long as you've written the problem and you've kind of said where you got stuck, I give you credit for the most part. But what should happen by test day? It should be done. Does that make sense? So that it's finished, that's graded, that's corrected, that's what we're grading. Is that cool for the homework spirals? Okay. But this is required. This is the final homework of Chapter 6. This is the one due by 7 a.m. tomorrow, and in the homework spiral needs to be ready to go. So what's the other thing? The handout that I gave you, the practice test. Okay? That is the other assignment, if I can get to it. Let's just go back here. The Chapter 1 practice test. Is the chapter review homework good? Yes! It's good on making you review all of the concepts covered on the test on Thursday. What is it not good for? How hard the test is going to be based on it being multiple choice. Does that make sense? It's great for making you review all the types of problems and the concepts and what you're going to need to remember and what you're going to need to be doing, but it's not going to help you necessarily, and this is where some people underestimate the test, on how hard the multiple choice will be. Now, if you guys notice, what did I attach to this guy? The test and the key. So if you guys scroll down, you're not just going to see, and I don't want to show it to you, but if you scroll down, there's going to be a blank page. There's going to be page 1, page 2, page 3, a blank page, and then right down here, key. I'm not going to show it to you because some of you have like this memory and you're going to remember, oh, A, B, B, B. I'm just kidding. I have no idea what 1, 2, 3 is. But anyway, the key is down there for you to look at, and it has my work shown, how the answers are what they are. Now, what did you just notice in Google Classroom about what I said about this assignment? Bonus. So does that mean it's required? No. Do you have to do it? No. Should you do it? Yes. Why did I give you an extra day of review? Because of this guy. Okay? Tomorrow in class, we're going to go over questions that you get stuck on in the review. And if there's extra time, we'll play around with multiple choice, and I'll try to give you some hints here and there, or if you've already tried the multiple choice. But my answer key with me in pencil form is in this document that you guys can check. Now, here's a dealio. Some of you guys, let's just think through. Let's be honest. You have a key. You have a key with work shown. And this is a bonus assignment. What's the temptation? Kind of, except I know my handwriting. But yeah, to go ahead and like, ooh, I'm just going to write down exactly what she did. Oh yeah, I got all these answers. It's perfect. Now, number 1, should your practice test be perfect? Because Thursday's not going to be perfect. I wish I could just grade and be like 100%. My job would be so easy, but it's not going to be. Your practice test, you need to try it, you need to get things wrong, and you need to figure out what am I not connecting. Does that make sense? Okay. So technically, do you have an integrity choice right here, whether or not to have integrity or not have integrity? Yes. But what is the best way to do this assignment? Try it, grade it, look at how it should have been done right. Try to figure out, could you do it on the test on Thursday? Does that make sense? Okay. So does the test come from these questions? No, not necessarily, but are these good multiple choice practice ones that should show you how they can get tricky? Yes. Okay. Now what does it say about the bonus? for the final exam, that huge final homework thing that we do, remember, can add 5 points. Well, I can't add 5 points. That's half a letter grade. But I made it 3. It's not 2, right? It's like halfway, but bumped up. I can add 3 bonus percentage points. So if you get like an 88, it would bump you to a 91. But that's only if you do it right. You got it. If you just circle A, B, B, D, D. Did you do anything? No. So I'm going to look at it. I'm going to see if it's actually done. You're going to actually turn it in to me in a pile. You're going to have your composition books, your homework spirals, and then your practice tests. Sound good? Yeah. Oh, I say pictures, don't I? You don't even need to give it to me. Never mind. Just put it in Google Classroom. You don't even need to hand it in to me on Thursday. I do have the deadline as 1 p.m. Why? Period 6 kiddos might be working on it up until the test, and it's not fair for me to give them extra time but not you. So I'm just making it 1 for everybody. That's the end of lunchtime on Thursday. Does that make sense? So should you probably have it done before the test? Yes, please. But I'm giving you the same amount of time that I would give period 6.
Should we upload pictures of it later?
Yes, please. That's a great question, Grace. On this one, I don't want just the attempt. Did I put attempt? Oh. I'm going to go ahead and change that to attempted and graded. Thank you. Because, yeah, you need to attempt it, grade it, and then, I would say correct it, but as long as I see the colored marks, where you've made mistakes, that's good. Are we okay on what these things are, guys? Ale.
Do we put the work that we're going to do on, like, the bonus inside of our homework spiral? Or do we put it on, like, loose leaf paper?
Let's say not your homework spiral, but you can totally put it in your workspace. So you can go back there to the scratch paper and like, just label it like we did today with what we're going to go over right now. Right after this, let me get to it. There we go. Right after this, you can go ahead and just put chapter 1 practice test, and you can work out stuff there. Yeah, but just a quick, I would only do that, Ali, if you need extra space, and here's the reason why. Tomorrow on the test, I'm going to give you more space. This one's really crammed. But tomorrow on the test, am I going to want all of your work on a set piece of paper? Not ideally. I'm not saying I wouldn't grade it. As long as you number it, this is 1, this is 2, this is 3. I will look at your scratch paper. But ideally, as much as you can show me on the test itself, it just helps me go faster. So I'm not saying you can't use, that's where I would put the work if I were you, scratch work for it, or just staple it to the assignment itself. But when you're taking pictures of it, the more that you can have on the actual test, the better. Is that cool? Okay. All right, let's go ahead and look at our bell work from the beginning of class. You guys got what we're doing tomorrow, right? The chapter review, going over as many questions as you need. The chapter review, the required homework. Okay. And if there's extra time, we'll go over practice test stuff. Hey, tomorrow morning is 0 period. Could come in and work on practice tests with friends. Yeah? Have the review already done. Has to be turned in by 7 anyway. You could play with the practice test. It's a good idea. It's a good idea. Or I'd say after school or tomorrow. Okay, for number 77. Y equals 10 is a horizontal asymptote. Which of the following must be true? Do we know there's a point at 10? Well, let's just say. What do you guys think the right answer is? Which of the following must be true? Ooh. Uh-oh. What'd you guys put? How many of you guys raise a hand? Who put A? Who put B? Who put C? Who put D? Okay. These ones were hopefully the top 2 answers, and they were in our class. Which one's right and why? C is right because horizontal asymptotes say what is going on as you go to an infinity. And as you go to an infinity, the function needs to be leveling out to a number. This one's tricky because it has all the right components, but they're in the wrong spots. Horizontal asymptotes, always, 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 you're going to infinity or technically negative infinity. What is the horizontal asymptote of the graph? What's the case? Top wins, bottom wins, tie. Top wins! Did you keep looking? Tie. Oh, struggle. Do you guys even have to worry about checking the signs? Nope. Fine. It's the only answer, right? B. But check the signs. You get a one direction, a positive over a negative, and in the other direction, a negative over a positive. Either way, negative. 79. Let's vote on this one. How many of you guys put 2/3? B? 3? C? D? Ooh, C and D are our top 2 answers. Okay, let's see what's going on. These are very different because one of them is a tie and one of them is a top wins. You guys see it? One of them is a tie, one of them is a top wins. Check it. Oh, I don't think top wins. I mean, it does have a 4, but what's the degree of the top? 1. What's the degree of a square root of a squared? Like a 1. So what technically is going on? Tie. So that's why D is not right. Now, am I supposed to square root the 4? No, just steal the 4 and square root the 1. 4 over 1 is 4. Well, right now, without even checking the sign, we know it's this. Check the sign, a positive over a positive is a positive 4. And that brings us down to number 80. Are we okay on 77, 78, 79? Okay. Do we need to study our degree tests and look at the tricky examples from notes with absolute value and square roots? Yeah. Okay, number 80. Multiple choice. I didn't want that. I apologize. There we go. Let this be a piecewise function. Now, this is a little tricky. This works for everybody but these 2 points. So this is everything, all the sides, but 2 points are missing. And this one got filled in. Which of the following statements about f are true? They're looking, it seems to me, at 4, right? Kind of? Talking about continuity, talking about a limit to infinity, and talking about a vertical asymptote. Continuity, what has to be true? Let's start there. Definition of continuous. A function is continuous if the following conditions are met. Number 1, f of who? So does f of 4 exist? Well, what is f of 4? Good. Okay, condition number 2. If the limit as x approaches c of your function f of x, well, wait a minute, who are we plugging into if we're talking about needing to approach 4? Top piece or bottom piece? Top. Why not the bottom? I need to approach 4. So I need to come from below and above. So where would 3.9 be? Here. Where would 4.1 be? Here. Only 4 is there. So I'm going to use the top piece, which is going to be x squared plus 4x minus 32 all over. Why am I doing x plus 2 and x minus 4? Because I think I'm going to have to, 0 over 0. Is it 0 over 0? Maybe I should factor the top 2. Has anybody checked yet? Was it 0 over 0? Because the top ends up being x plus 8 and x minus 4. Is that right? Yeah. So plug in 0 over 0. Keep going. Oh, the limit doesn't. Yes, it does. Because how do you keep going? You can cancel. Well, technically reduce. Canceling is to 0. Now, how do you finish solving the limit? So that'd be 12 over 6, and 12 over 6 is? What needs to be true about f of c and the limit as x approaches c of f of x? Condition number 3. They have to agree. So do they agree? Do you guys agree with the 2? I didn't even hear. We're okay? So does 8 equal 2? F of 4 does not equal the limit as x approaches 4 of f of x. So what's true about? Oh, that's true. Good. Careful. Which of the following are true? They could also say are not true. Just watch out. Are true. Yes, it is not continuous. Okay. Whew. That was condition number 1. Yay! Condition number 2, or Roman numeral number 2. How do I take a limit to infinity? What piece am I plugging into? Why not the bottom? It's only one little baby point. If I'm trying to go to infinity, I need to look at the graph, right? It's okay. We're trying to get this. We're trying to get this figured out. This is on the left of -2, on the right of -2, on the left of 4, on the right of 4. This guy is everything but one little baby point. So if I'm trying to go to infinity, I need to, 10, 100,000, million, they're all in this piece. So then what happens if I take that piece and if I take the limit as x goes to infinity of that piece? What case is it, guys? Tie. Good. You guys see my greatest magnitudes? What's the ratio of leading coefficients? 1. Careful, just because there are trickier functions out there. Plugging in a positive squared. Positive. Plugging in a positive squared. Positive. So it's going to be a positive one. Positive over a positive. Okay. Ha 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 ha. Not you. Okay, how about number 3? Got to go back to the summer review packet and pre-cal for this one, but you guys can do it. Go to calculus also. Is it 0 over 0 at 4, or is it number over 0 at 4? Who is it in the function? 0 over 0 at 4. 0 over 0, does that keep going removable discontinuity, or is that stop infinity and beyond non-removable? Keep going. So is it a whole, or is it a vertical asymptote at 4? A whole. Vertical asymptotes are number over 0. So negative 2. Negative 2 is a vertical asymptote, number over 0. Non-removable, infinite. The whole, that's the one where the limit can still exist as long as the approaches agree. So therefore, that's a no. The final answer is letter A. Okay. Let me go ahead and do this. For those of you guys that haven't written down the, let's go past those. This is showing you that the chapter 1 in your book also has a practice test. If you want even more practice besides the chapter review I'm requiring and the big old practice test that I'm allowing, I mean, I guess you can go in and do the chapter practice test in the book too. But, struggle. Where am I going? Keep going. Here we go. Kiddos, at the very end, this is review, not practice test. At the very end of the notes online, to the test review. The calc chat answers to the test review, the odds and the evens. Why would I put this here? What do I want you to do before tomorrow? Try it, Ruth said it, and grade it. The evens and the odds. You don't need me to pull up the answers tomorrow, right? So even though this is going to be a big temptation, I think all of us feel the weightiness of the test, the 100-point test on Thursday. That's going to somehow offset our summer review one that had 50 free points in it for just doing the handbook or just doing the packet, okay? So if we feel the weightiness, then you know you need to get into this review, try all the problems, get to this answer key at the very end. It's going to be saved in the notes online. Does that sound good? If you want, I can also, that would be nice. Let me go ahead and save these pages as a PDF, and I'll attach it to your assignment on Classroom. Is that good? Then you can just quickly access the key and then grade it. So for the test review, can we go ahead and have you submit the attempt with the grading? Is that cool? All right, I'm going to change attempt and grading with both the review and the practice test, and I'll see you guys later. You got it. We have one more full day, but you need to review tonight. Bye, guys.